Good morning to everyone. Today we are in the fourth part of the project management video lesson. Here we are going to talk about a simple example of using the Gantt chart on the network diagram for a company called Pine Valley Furniture. So let us try to see this example to understand it very clearly. What are the steps in developing this Gantt chart or the network diagram? Very simple. First, you have to identify each activity. That means, as I told you before, the project is divided into many small parts. So here your task is actually to identify each activity. You have to identify what are the activities that are there in the project. So you are going to divide the project into many small parts. Look at this one. First one is we have to collect the requirements from the end user. Then you are going to, based on the requirement design, you are going to design the screen. Then you are going to design the reports, outputs. Screen is inputs, the report is output, and you are going to store the data which is actually going to be stored. So you are going to design on the database storage. Then you are also going to have something called user documentation, which is going to actually act as a clear understanding manual for people who are going to use it. And after that you are going to do the programming or software development. Then you will install and test it for any bugs or any validation errors like this. So basically the project is divided into 7 different activities. So we are going to see that these activities either can move parallel or it can go sequentially. One activity may depend on another activity. This is what we are going to show in a form of a network diagram or in a Gantt chart. First of all, step 1 is to identify each of these activities. Once you identify the activities, you are going to write down the activities. This is actually like we are going to find the time estimates. What is time estimates? How much time will be taken to complete each of this? Please look at these words here. We have got something called time estimate, and this is in weeks. How many weeks it will take? O is actually called optimistic. Optimistic means very good situation. I can do it in 1 week. That's the best I can do. Realistic. What is the R? R is realistic. Sometimes people call it with M also. What is M? Most likely. Okay, there are 3 scenarios. You are planning to do something, but it is the best scenario is 0. O means what? Optimistic. What is actual ideal? Ideal means what is going to happen mostly is R, realistic. What is P? Pessimistic. In the worst scenario, if whatever the plan you did, it's not going to happen in the way how you want to see it, that's actually called pessimistic. Pessimistic means the worst. You can say here the best case, the worst case, and the most likely case. For example, this can be done in 1 week. This can be most likely completed in 5 weeks, but in the worst case it can be completed in 9 weeks. There are 3 scenarios for all these things. Okay, installation 111. Why 111? In any case it can be finished in 1 week. Worst also 1, best also 1. Here you can see that user documentation, the best is 3, the worst case is 7, and the most likely, what is the nominal or expected one, is 6. Okay, now you see, using the time estimate, I am going to give the expected time, ET. There is a formula for this one. O plus 4 multiplied by R plus P by 6. O plus 4R plus P divided by 6. Okay, now in this case you can see here, in this case you can see here, now we have 1 plus 4 multiplied by R. 4 into 5 how much? 20 plus plus 9. So 30 divided by 6 is 5. I repeat again, 1 4 into r is 5, 4 into 5 is 20, 1 plus 20 plus 9, 30, 30 divided by 6 is 5. So you actually get the expected time is 5 weeks. Now our time estimate, and we want to get the estimated time. How much it will take approximately? 5 weeks, 6 weeks, 6 weeks, 2 weeks, because these are the three scenarios. You never know in any project whether you are going to have the best scenario, or you are going to have the worst scenario, or you are going to have a mean scenario which is most likely to happen. So in this scenario, you want to actually calculate the expected time. To calculate the expected time, the formula is 0 plus 4r plus p divided by 6. I hope this is very clear. Now we found out the expected time ET for all the 8 tasks. Okay, before I said 7 tasks, now I can say that it's 8 tasks. Okay, now the third activity that you are going to do. First one is identifying the activity. Number 2 is calculating the expected time based on the time estimates, which is of 3, optimistic, probably, or the next one is pessimistic. Okay, now R is realistic. Okay, now you can see here there is preceding activity. We are going to determine the sequence of activities. Like there are 8 activities, which should start first. Now you can see here, this is the first task I am going to do. So there is no activity before this. So that's why I give a hyphen here, mentioning that there is preceding means before this. Before this there is no activity. That means this is the first activity. Requirement collection is going to be what? The first activity. Is that clear? Number 2 is what? Screen design. Number 3 is report design. What does it mean? See, you based on the requirement collection only you can do these 2 activities. So before this activity start, you should complete before you finish 2 and 3. Before you start 2 and 3, you should complete activity 1. You understand? Now look at 4. 2 and 3 should be completed if you want to start 4. Okay, only when the 4 is done you can do 5 and 6. Okay, 5 and 6. 7 depends on 6. Only when the programming is complete you can test it. Installation depends on 5 and 7. 5 and 7. So you see, so from here what you can understand, the first task you will do is this one. Then these 2 tasks you can do simultaneously, maybe independently, parallelly you can do. Then once you can do this one, you will go for this one. Then these 2 tasks can be done parallelly. Then you can go for this one and you can go for this one. So this is the sequence of activities that you are going to follow. Now this is how the critical path will be defined. We are going to draw a network diagram. You can see here, first activity is requirement collection. You see here these 2 are parallel. I told you these 2 are parallel. It only depends on these 2. So you just put it here. That means you can employ some people for screen design. Some people you can employ for report design. Then you go for database design. Then again you can see here 5 and 6 are done based on 4. Okay, now 5 is 5. Then you are going to do programming and testing. You can see the previous one. 5 programming is done. Okay, 4 testing is depending on what? Programming. Testing is depending on programming. Installation depending on 5 and 7. You can see it here. Installation 5 and 7. Okay, testing is depending on 6. So this is actually called, okay, that's how you are going to show it. Is it clear now? The critical path, how the work should be done. A scheduling technique means what? Whose order and duration of a sequence directly affect the completion. If you are going to follow this step, your project will finish on time. If you are going to do, like for example, I will start installation first, I will do project user documentation first, then it will affect the whole project plan. So you have to go by the sequence of events so that the final delivery date will be short and you will get the product. Critical path is actually what? The shortest time in which a project can be completed. The best path. That means activity 1 is the first one. From 1 you go to 2, from 2 you go to 3, 3 you can do 4, like this, or 5. It is not necessary it should follow a number sequence. It can be different. So you have to determine which path has to be followed in order to ensure that the project can be completed on time. The next one is what? Slack time. What do you mean by slack time? The time the activity can be delayed without delaying the project. That means sometimes I told you there can be a situation that you want to do a particular activity in the project, but you don't have the people. But at the same time, there is another activity which needs somebody's support immediately. It will affect the project delivery time. Then you can actually switch the person to that one and make this task to wait, because it is not going to affect the schedule, but that delay which is going to happen on the other activity can affect the project delivery time. I think with this we will stop for now for the part 4. I think we are in part 4, and then we will continue in the next video lesson, the last part of the project management.